Okay, well, I hope I'm recording this correctly. So 4.3 is graphing tangent and cotangent. I'm not going to spend a lot of time on these. I want you to be able to, we're not going to deal with any phase shifts or anything for tangent and cotangent. I just want you to know a few fundamentals, how these differ from sine and cosine. If you want to figure out, I've got some animations that kind of show where this come from. You can take a look at those. We're not going to pull through these. We're not going to go through these right now. There are some major differences. The period is smaller. This thing repeats every pi rather than every 2 pi. There is no amplitude. Amplitude is your max or your minimum. This thing has no maximum or minimum. It just goes up to infinity and down to negative infinity. Now, the way I remember these kind of key points is I know tangent is sine over cosine. So I take my sine and my cosine at just a few points, and I see what tangent has to be. So I look at these. Let me close this out. That's already closed. Okay. I look at what happens at 0 and at 1. 1 and 0. Every 90 degrees, so at 90, 180, 270, 360, sine and cosine are all going to be either 1, negative 1, or 0. Okay. And depending on which one of those you have, that will tell you what's going on with tangent. Either it's going to be 0. So for example, when x is 0, so when your angle is 0, sine is 0, cosine is 1, tangent is sine over cosine. Well, that's 0 divided by 1. That's also just 0. At 90 degrees, or excuse me, pi over 2, 90 degrees, pi over 2, same difference. Sine is equal to 1, cosine is equal to 0. 1 divided by 0 is undefined. That gives us this black line I've got drawn in this horizontal asymptote. So what's happening is we're going from 0 up to this undefined, up to this asymptote. And you can kind of use this reasoning for each point along the way. As for knowing which direction you're coming from, from the positive, or going up in the positive direction, up in the negative direction, really that has to do with what, where your other values are coming from. Are they coming from the positive or negative direction? But I'm not going to require you to know any of that. You just need to know the rough shape of this graph. If you want to know, I'm more than happy to talk to you about it a little more. Cotangent is the same idea, but everything is upside down. Everything is the reverse. Rather than starting at 0, this has an asymptote to begin with. Right, so we started at an asymptote, and we go down from there to 0. So notice our graphs here are going kind of up and to the right. These are reversed. We're going down and to the right. So not only do they start at an asymptote rather than 0, they're going the opposite direction. That's all I want you to know about tangent and cotangent. So that should be a really easy section for you. In fact, yes, I want to leave. Okay. 4.3. The homework is super easy for this section. I used to call this the tiny 4.3, 4.4. There's only 4 questions. I want you to be able to tell me what tangent looks like. Tangent looks like that. Go up and to the right. Okay. Similarly, cotangent, yes, I know, I don't care. Cotangent has an asymptote right there to start with, and I'm going down and to the right. So which one of these is it? You have to remember your period for that. The period of cotangent is pi, just like the period of tangent is pi. Boom. So that's a super easy homework section for you. Oops. There we go. Okay, I can also go ahead and start on 4.4. Actually, we can do 4.4 in the same video. 4.4 I've got drawn here along with, I've got your secant and cosecant graphs drawn along with their inverse or their reciprocal functions. Secant is the reciprocal of cosine. So what that means is if you take 1 and divide it by your cosine value at any given point, that would give you your secant. So, for example, we're going to follow along our little graph here, our little pink line here. Starting off, cosine is equal to 1. It's right here. So I take 1 and divide it by 1, I get 1. So right here, secant and cosine have the same value. As I go down here, my cosine is getting closer and closer to 0. This is probably the coolest, I don't want to say coolest. This is a very powerful mathematical concept to know. If you know this, it can make a lot of chemistry, it can make a lot of applied math a lot easier. As I'm getting closer and closer to 0, I'm getting a smaller and smaller number. So the concept here, so as I'm going from right here, our first little interval from 0 to pi over 2, where our first asymptote is, I'm taking 1 and I'm dividing it by my cosine value. I'm dividing it by my y value, which is getting smaller and smaller. What happens when I divide a number by a smaller and smaller number? Well, we can ask Google. What happens when we take 1? Let's say we take 1 and divide it by 0.5. That's pretty small, right? I get 2. We'll say what's something smaller than 0.5? Let's say I have 0.25. Oops. That's about half as big. What happens to my y value? I'd go to 4. So I'm getting a little bigger. Let's say I divide by, let's just say 0.01. So really small number. Okay, now I've rocketed up to 100. So you see, as I'm dividing by these smaller numbers, I'm getting bigger and bigger numbers. And that should make sense. If I take 1 and divide it into parts that are 0.01, how many do I have? Well, I would have 100 of them. You could say, like, if I have $1 and I divide it into pieces that are each 1 penny, how many do I have? I have 100. If I had some fraction of a penny, let's say I had half a penny, that would be 0.05. How many would I have? That would be 200, right? Yeah. So as I'm dividing by smaller and smaller numbers, and I'll make it really big, I'll make 0.001. You see, I'm getting larger and larger numbers. Let's say I divide this by 0.000001. So dividing, well, I don't even know what this is. 1,000 millions. 1, 2, 3 billions. This is 10 billion right here. So as I'm dividing by smaller and smaller numbers, I'm getting a larger and larger result. That is why our graph is just shooting up right here so quickly. And at this point, at 0, what's going to happen? Well, we can't, it's not defined. We can't define that mathematically. This is going up infinitely. So as we get closer to 0, we're getting a smaller and smaller number. It's making this rise really quickly. Okay. It's the same idea over here, but these numbers are negative. So if you think of it now, I'm kind of going backwards. If I'm going from right here at -1 down to 0, I'm getting smaller and smaller numbers right here. So I'm dividing by smaller and smaller numbers, which is giving me larger numbers just in the negative direction. So we could do this exact same reasoning, but with negative numbers. Let's say I have negative 0.0, sorry, negative 0.01. I get negative 100. 1 divided by negative 0.001. Negative 10,000. 1 divided by negative 0.0001. That's not 10 billion again. It's 10 million, whatever. So as we're dividing by smaller and smaller numbers, we're getting a really large number, but large in the negative direction. So you see our secant is going down to infinity in the negative direction. So that's kind of where these come from. You can draw out cosine, you can draw out sine, and just know that your cosecant or your secant will be bouncing. It will look kind of like a parabola, but it'll be kind of trapped by your asymptotes. And the asymptotes are really easy to find. They're wherever either your sine value equals 0 or your cosine, depending on which function. Now these don't have an amplitude, but they do have a starting point. It'll be wherever sine or cosine starts. But again, I don't ask you anything exciting like that. Let's see what I do ask you. Nothing too crazy. Cosecant, so this is the reciprocal of sine. Sine bounces between 0 and 1. That means our first asymptote is right here at 0. Right, so we've got our first asymptote. So that would have to be this one. So all I ask you for the secant and cosecant is to be able to identify those graphs. Okay. It's a very easy section. Spend your time kind of getting used to this idea of dividing by a small number and that giving you a very large number, because it's a very powerful concept to be able to think of, well, what happens as I start dividing by smaller and smaller numbers? Okay, that should make me shoot up into infinity.